in Bregenz. We have come to meet Sebastian Hülck, who is Director Segment Lighting at EBV Elektronik. Hello, Sebastian. Thank you very much for meeting us.
Hello. Nice to meet you.
Can you tell us a little bit what you're showing here at LPS?
So in general, what we have here is industry lighting and also general lighting. So if we start here, this is an example for entertainment lighting. So it's our French customer Ayrton. They are using the Osram Oslon Stage Generation 2 in conjunction with some French custom optics. So you can see here an example from the Frankfurt ProLight and Sound, which was completely illuminated by this magic panel and the magic dot, which is quite a unique and new product. The magic dot, for example, is using a high diameter specialty optic, resulting in a very high luminous intensity, which is unprecedented. And you can see these stunning effects if you combine those parts together. What lighting scenarios you can create from that, right? So if you move on, here we have the general lighting section. So this is a color tunable troffer, so a typical 60 by 60 troffer, which is featuring, as you can see over there, the new Osram chips care package Duris S2. Inside this color tunable panel, we have integrated finger type modules, which are populated both by cold white and warm white Duris S2s. And then here we have that Infineon control, so it's based on an Arduino XMC1200 coming together with an Anakin Bluetooth shield and an RGB shield. With that, I can get access via the smartphone and steer in between the different color temperatures. What you see here, and that's actually smart lighting. So this, the subject for that would be human-centric lighting. So this is a color tunable troffer, a 60 by 60 troffer that you can recess into the ceiling, and it's equipped with the new Osram Duris S2 chips care package, both in warm white 2700 Kelvin and in cold white 5700 Kelvin. So the control we have realized here is based on an Infineon XMC1200 microcontroller. So this is the Arduino shield. There's also the RGB shield and the Anakin Bluetooth shield. I'm using an app here on the iPhone, and this is the GUI. And what I can do here, as you can see, is switch or toggle in between cold white and warm white. And I can also dim up and down. So this is actually smart lighting, right? So human-centric lighting, because you're kind of simulating the artificial sunset and sunrise that you bring into the office, because it's more healthy for humans. That's why we call it human-centric lighting. So as we move on, what you can see over here is equipped with a lamp called Neonica, or Rowie from our Polish customer Neonica. So it's basically featuring all the wavelengths that the plants, the crops need to grow. So it's deep blue, it's far red, it's hyper red. So all these wavelengths that the plant needs for the photosynthesis process. What the plant doesn't need is green. That's why it is green, because it's reflecting green color. But red and blue is really what it needs, and that's what is realized here. So it's a much more efficient solution rather than using only white, right? So this was a mid-power section. This is the Osram chip-on-board section. If you look at that, on the left-hand side, we have realized a solution for supermarket lighting, especially for fruit lighting. If you look at these color checker charts here, for example, especially at the red here, if you may come closer with your camera, you might see that. If you compare, especially here, the R9, so the red, with that one, or the yellow, there you can see that as well, you will figure out that the red one is popping out here. That means it's oversaturated. So this is what Osram calls the brilliant color. And this is the 3000 Kelvin Sierra 90 chip-on-board version. What we have here is a difference, or to show the difference in fashion retail. For example, in between a cream-colored shirt and a white one. If I put it here, it's harder to distinguish in between the colors. They all look the same. But if I use this one, you can immediately see there's a difference. This is cream-colored and this is white-colored. So this is called the brilliant white, or the below black body locus version, where you can show these differences. What is also interesting, here you have 3000 Kelvin, here you have 4000 Kelvin. If I take this nude colored high heel shoe, and if you compare this one, it's the same shoe, with that one, you can really figure out, it looks like it's different colors, right? But it's just a matter of the color temperature. So this is 3000, this is 4000, and this is real color. So if you notice the difference, it's amazing. What you can here, or you can do here, if you can you hold that for a moment? No, I mean the microphone. So if you look at the differences here, which one do you prefer more? Which one looks better?
I like this one.
You like this one,
Yes.
right? That's a correct answer, because here the color is oversaturated, so the red pops out. So for fashion lighting, this would be the right choice. And in this case, you cannot really see the difference. This is featuring the new Osram Duris S8, so it's a small LES device, a small chip on board device, and this is the standard LES version, also CRI 90. But what you can see here, I mean, it's probably not clear on the camera. This has a higher CBCP, that's the center beam candela power, the punch of the light. So this varnish here, or this lace, has a more glossy effect, which you want to create if you sell these kind of shoes. So this is why we have different kinds of chip on board devices in clothing retail chains. What you have over there, this is a high power section, is a new Osram Oslon Square spray coated version. In this case 3000 Kelvin, where we're using a 2x 60 watt digital driver. So digital drivers, like in this case used the ST Lux driver, are prevalent in the server and computing space because you have variable loads. So you want to squeeze out the maximum efficiency all the time. This is quite kind of new to the LED lighting world, to SSL. And with that design, we can maximize the efficiency. But it's also featuring a very good line regulation. If you wanted to, very low power consumption, high power factor correction, low current ripple, and all these advantages. In the next version, this is what you can see here. This is an NFC device. NFC stands for near field communication. It has been originally developed for POS payment processes. With that device, if we add it, this is inside this Citeco fixture. You can even program the current by holding a reader against it or using your smartphone again. Yeah? So this is used for current setting in the driver. Yeah. So we move on to the industrial section, or back to the industrial section. What we have here is a matrix light. So a matrix light means, if we look at the throw over there, you have a lighting pattern. And if you're going down the streets and something is coming up in your way, I'm trying to simulate that here, you blend out those sections where someone is approaching you to avoid glaring this guy. So in the end, if I turn on high beam, you can keep it turned on all the time, because the intelligence system is permanently calculating where someone is in your way, and then just turning off those areas where there shall be no light. is a very complex system. But this is, for example, in the new Audi A8 or in the BMW 7 Series coming from the company Hella, using Osram compact LEDs. So last but not least, what we have over there is a surgical lamp, right? So this is coming from the German manufacturer Dr. Mach. So what they usually want to have, this is again fully LED lit with some specialty optics, is really bundling the light to one central point. So these optics are made in a way that you have the maximum light intensity and also lux value concentrated here in that beam. And this is featuring also Osram square LEDs. So you see what different applications you can realize with Osram. And we as EBV, we are a pan-European distributor, actually also the biggest Osram distributor in the world, and we cooperate with them. Thank you.